Hey everyone! Welcome back to BugNoJutsu. In today's video, we're going to tackle an interesting problem from Leetcode: remove subfolders from the file system. This problem is all about understanding folder hierarchies and efficiently removing redundant subfolders. It's categorized as a medium-level problem, but with the right perspective, you can solve it easily using some basic string logic. Let's dive right into it. You are given a list of folder paths, where each path represents a folder in a file system. Your task is to return a list containing only the top-level folders, after removing all subfolders that exist within any other folder in the list. The result can be returned in any order. A folder is considered a subfolder of another if its path starts with the parent folder's path followed by a //. For instance, the folder /a/b is considered a subfolder of /a because it starts with a, but /b is not a subfolder of /a/b/c since it does not begin with that exact path followed by a /. The format of each folder path is defined as one or more segments that start with a // followed by one or more lowercase English letters. Valid examples of such folder paths include /Leetcode and /Leetcode/problems, while invalid paths include an empty string and a single // without any letters. The goal is to filter out and return only those folders that are not contained within any other folders, according to the rules described. Let's walk through an example. Suppose the input is /a/b/c/d/c/d/e/c/f. We want to return only the top-level folders. So we look at /a, it's clearly a top-level folder. Then /a/b, well, it starts with a, so it's a subfolder and we discard it. Next is /c/d, again, it's a top-level folder, so we keep it. Now /c/d/e, this is inside /c/d, so we skip it. Finally /c/f, this one is not under any previous folder, so we keep it. The final answer is /a/c/d/c/f. Now let's understand how we can solve this programmatically. The first smart move is to sort the folder paths lexicographically. That means they'll appear in dictionary order. Why do we do this? Because parent folders will always come before their subfolders. Then, we go through this sorted list one folder at a time. We keep a result list that holds our top-level folders. For each folder we check. If our result list is empty, it means it's the first folder and we just add it. Otherwise, we compare the current folder with the last folder we added to the result. Here's the key logic. We check if the current folder starts with the last added folder plus a /. If it does, it means it's a subfolder and we skip it. If not, it's a valid top-level folder and we add it to the result. And that's it. We just loop through once and build our final answer. Let's talk about time and space complexity. Time complexity is O(n) log n, because we sort the list of folder paths first. Then we do one linear scan through the list, which is O(n), so overall it's O(n) log n. Space complexity is O(n), to store the result list. We're not using any complex data structures here, just string comparison and list storage. There are a few important insights to take away from this problem. First, sorting is a powerful tool when dealing with hierarchical data. It simplifies many problems. Second, string prefix checking is enough here, you don't need complex tree structures unless the constraints are huge. Third, handling edge cases like /a versus /a becomes simple when you always add a / during prefix checking. That ensures you're checking for a proper subfolder, not just a path that starts similarly. And finally, this problem is a great real-world example of how file systems work under the hood. That wraps up today's walkthrough of Leetcode 1233, remove subfolders from the file system. If you found this explanation helpful, please hit that like button and subscribe to BugNoJutsu for more algorithm breakdowns and deep dive coding tutorials. And if you've got questions or want me to cover a specific problem, drop it in the comments, I'm always happy to help. Thanks for watching, and I'll see you in the next one.